In the context of an aging society, choosing soft foods is especially critical. Liquid foods require a certain degree of cohesion and adhesion to reduce the risk of choking during consumption. Moreover, infants and patients with swallowing difficulties face similar risks. So, which probes can we use for analysis? We can think about soft foods from three aspects: security, comfort, and happiness. Let's first learn about the accessories that can be used to meet the requirements in terms of safety. Besides basic ingredient testing, for people with swallowing difficulties, how easy the food is to bite and swallow is also an important consideration. We can analyze this using relevant standard methods. Currently, there are three standard testing methods: Japan's UDF, the International IDDSI standard, and Taiwan's E-tender, all with their own grading systems and automatic grading mechanisms. Japan was one of the earliest countries to enter a superaged society, gaining significant experience in dealing with population aging. In 2003, the Japanese Care Food Association, initiated by the food industry, established a standard to ensure the dietary safety of people with swallowing difficulties. This standard includes three baseline criteria: hardness, adhesiveness, and cohesiveness, measured by placing samples in containers of the same size and compressing them twice with a 20 mm probe, yielding values for these metrics. In addition, the Japanese Dysphagia Diet Plan developed by the Japanese Society for Dysphagia Rehabilitation integrates and compares three grading methods: DDP, Dysphagia Diet Pyramid, FPD, Food for Dysphagia Patients, and UDF, Universal Design Food. In 2015, the IDDSI standard was established, providing a food and liquid texture grading system recognized by many countries. The tests cover solid food testing for grades 4 to 7 EC and liquid testing for grades 3 to 5. Solid tests include fork separation, fork pressure, and spoon pressure methods, while liquid tests include fork and spoon drip tests. Fork separation can determine whether food meets levels 4 to 7 EC, fork pressure and spoon pressure can assess levels 4 to 6, while fork drip and spoon tilt can assess level 3 or levels 4 to 5. In 2023, the Chinese University of Hong Kong also published a paper that made various foods into forms that meet the IDDSI scale of 4 to 7 and compared them with the values of the UDF test. Data shows that IDDSI level 7 corresponds to UDF level 1, IDDSI level 6 corresponds to UDF level 2, and IDDSI level 6 corresponds to UDF level 3. In 2021, Taiwan E-tender refers to the International General Method, and at present, in addition to referring to the Japanese standard for nursing care food, semi-solid food uses a probe with a diameter of 20 mm for TPA for secondary compression, and considering regional differences, it switches to a metal probe with a diameter of 3 mm for solid food. According to the measured hardness, it is divided into 4 grades: easy chewing, gum chewing, tongue crushing, and no chewing. The term E-tender comes from the translation of the English word bartender. Each word has its own meaning, which includes elderly, affordable, thoughtful, easy, nutritious, delicious, enjoyable, and reliable. When the food passes the safety test, but if it is not delicious, it will be difficult for people to swallow, so the importance of deliciousness is self-evident. However, everyone's definition of good is different. Some people like hard food, some people like softer food, so how do we judge how good food is? At this time, we can use accessories that simulate sensory tests to show our eating action realistically. For example, the Zhejiang Gongshang University FOP laboratory has established and developed a food soft friction test device to simulate the mastoid phenomenon on the real tongue to produce a rough surface, and then obtain the smooth feeling of fluid food rubbing on the tongue. The Zhejiang Gongshang University FOP laboratory has also published several articles on oral friction, and even the astringency effect of red wine and the correlation between the perception of tea sweetness and the friction coefficient. The solid sample can be simulated by the MEC to simulate the chewing action in the mouth, and the temperature control device is added to maintain the temperature of the oral cavity, and the saliva enzyme is added to reduce the food agglomeration effect. The operation mode of the experiment includes oral process actions such as compression, stretching, extrusion, and shearing, and simulates the chewing of food in the mouth. The sample in the picture shows that the food will begin to erode after about 10 chews, and the measured results are fitted into an energy decay diagram through the software conversion function. Different brands of noodles also showed different decay patterns, showing whether the sample softened and chewed well. Semi-solid or fluid samples can quantify the flow behavior in an extrusion manner, with excessive flow in sieving out the ability to choke on the level. This analysis method is also applicable to infant complementary food in the nursing population. Excessive flow of water and juice, and if it is some relatively thin samples, thickeners can be added to increase the consistency of the fluid and avoid choking on people who eat it. Finally, we must consider that if there is no desire to eat, it is in vain to consider safety and nutrition, and most of the care foods are made into puree or paste forms that are easy to swallow, but they do not have the appearance they want to eat. Therefore, the shape of provoking the desire to eat is the future direction and challenge for food manufacturers. Vision is the trigger point of appetite, and how to shape the appearance is currently a potential market for many 3D printed foods. The hardness, density, tension, thickness, adhesion, cohesion, and other flow characteristics of the material determine the success or failure of the printed product and the key indicators of durability without deformation. The design of food texture can be carried out by simulating the inkjet state of 3D printing technology through the forward extrusion to meet the specific needs of the production of customized food. A considerable amount of literature has been published on 3D printed food to study the appearance of food, and the technology that can be commercialized is still under development. Whether the shape and size of the printed product can be the same as the design, the shape durability can be scanned by the laser of the volumetric analyzer, including volume, length, maximum width, maximum height, specific volume, density, surface area, slice area, perimeter, radius, and other indicators. Data and graphs can be viewed backwards in 2D or 3D views. The geometry of packaged foods can all be monitored together. In the direction of the fittings, it is possible to consider whether the choice is based on standard methods, whether the sample form is liquid, semi-solid or fluid, and the needs of the process. In addition to the above-mentioned food safety and taste considerations, the packaging of the unopened product is also a carrying indicator. Through the texture analyzer device to simulate the opening of cans, tearing off the packaging and other tests, we cannot ignore the goodness of improving packaging.